Alright, let's look at some more examples of graphing rational functions. Let's look at the function negative 4 over x, right? So we can see that the parent function is 1 over x, so you can see we had two changes. Instead of it being a 1, it's now a 4, and it's now negative. So let's look at what that does to the graph when we have changes like that. As always, I'm going to start with my intercepts. I'm going to start with my asymptotes. So in this case, I'm going to set this denominator equal to 0 to find my vertical asymptote. So x equals 0 is my vertical asymptote. So I know I still have an asymptote right here at this axis. Alright, now I'm going to do the same thing. I've got a bigger exponent on bottom, so I know that my horizontal asymptote is y equals 0. So it didn't change my asymptotes any. My asymptotes are still the axes. Alright, but let's look at what it does if I was to graph my intercepts, right? So let's look at my x-intercept. Okay, so for my x-intercept, I'm going to find 0. So I'm going to set this equal to 0. So I've got 0 equals negative 4 over x. Alright, I'm going to multiply by x on both sides. Those cancel out. X times 0 is 0, so 0 equals negative 4. So we do not have an x-intercept, right? Obviously, because my asymptote is at 0. Alright, but let's find our y-intercept. So if I was to plug in 0 for y, oh my gosh, it's undefined also. So there is no intercepts. Okay, now, holes in the graph. Okay, if I have something that can cancel out on the bottom or the top, we have a hole in the graph, which in this case is none. So my graph looks like this and like this. Alright, so now we'll talk about what changed. If I was to graph a point, let's say if I plug in 2 here, I've got positive 2, so x is positive 2. I have negative 4 over 2. That's going to become negative 4 over 2, which becomes negative 2. So I have a point at 2, negative 2. So 2, negative 2. Alright, I'm going to do the same thing here. If I plug in a negative 2, I've got negative 4 over negative 2, which gives me a positive 2. So at negative 2, we have positive 2. Now, comparatively, okay, to the parent function, that point is farther away from my origin. We call that a vertical stretch. So this is a vertical stretch here by a factor of 4. Alright, now, with all that being said, don't worry about it. Let's talk about some other stuff, right? The domain is still from negative infinity to 0, union with 0 to infinity. The range is still the same thing, negative infinity to 0, union with 0 to infinity. Alright, again, the intercepts, none. Symmetry, so we've got negative 4 over negative x. Alright, so now, if we get negative 4 over negative x, we get positive 4 over x, which is the exact opposite of this. So we have odd symmetry. Is it increasing, decreasing, or constant? Well, it's decreasing across the intervals from negative infinity to 0. And from 0 to infinity. My end behavior, so as x approaches negative infinity, y, or f of x, approaches 0. As x approaches positive infinity, y approaches 0. But as x approaches 0 from the left side, so from this side, from the negative side, f of x approaches infinity. And as x approaches 0 from the positive side, f of x approaches negative infinity. So now from the parent function, these are flipped, right? So what we had is we had a reflection over the horizontal asymptote, or over, in this case, the x-axis. All right, let's look at number 5. Number 5, I can see I have transformation, a transformation, a transformation, and a transformation. So this is going to be a totally different graph. Alright, so as always, like I said, let's start with our asymptotes. Alright, so I'm going to set the denominator equal to 0. I know my vertical asymptote is going to be at x equals negative 2. Alright, now to find my horizontal asymptote, bigger exponent is on bottom, so again, same thing, horizontal asymptote is at y equals 0. But is it really? Okay, because this is going to move the graph up or down. Alright, so in this case, I have a transformation where we're moving the graph 1 unit down. It's going to move it to an asymptote of negative 1. So there's my asymptote right there. So I've got my asymptote at y equals -1. Bam, there it is. All right, so now let's look for our intercepts. Okay, in this case, we're going to set 0, plug in 0 for x, excuse me. So I've got -3 over +2 minus 1. So I've got -3 halves minus 2 halves, I could say, which is going to be -5 halves. So at 0, -5 halves. Okay, or -2.25. Same thing for the y, or for the x-intercept, I guess you'd say. All right, so I'm going to set this equal to 0. So I've got 0 equals -3 over x plus 2 minus 1. We're going to add 1 to both sides, so 1 equals -3 over x plus 2. Let's get rid of our denominator, so let's multiply by x plus 2 on both sides. Well, 1 times that is just itself, so x plus 2 equals -3. Now subtract 2, x equals -5. So we got x equals -5, 0. So we have an intercept at -5, 0. All right, so now my graph would look like this. So let's talk about the domain and the range. Oh, sorry, x-intercept's -5, 0. We know we don't have any holes because nothing cancels out, so there's none. Domain is going to be from -infinity to what? Well, it's going to approach this vertical asymptote right here at -2. So -infinity to -2, not to 0, union with -2 to infinity. Same thing for my range. My range is going to go from -infinity to my horizontal asymptote, which is at -1. So -infinity to -1, union with -1 to positive infinity. Is it even, odd, or no symmetry? All right, let's look at this. So I've got -3 over -x plus 2 minus 1. Well, that's going to be -3 over -x is a +3 over x plus 2. Sorry, I can't do that. So now let's look at this. Okay, if I was to take the negative out of this, this would be -3 over -x minus 2 minus 1. So this could be +3 if I was to cancel out my negative. So +3 over x minus 2 minus 1. Is that the same as this? Obviously not. Is that the exact inverse of this? No, because that's still a -1. It was a -1, it's still a -1. So is it symmetric? No. Neither. Odd nor even. Increasing, decreasing, or constant. Okay, so as this graph is going this way, it's increasing. And then as the graph is going this way, it's increasing also. So it's increasing across the interval from -infinity to -2, union with -2 to infinity. So my end behavior here, as x approaches -infinity, f of x approaches -1. As x approaches positive infinity, f of x also approaches -1. And as x approaches -2 from the left side, it approaches positive infinity. And as x approaches 2 from the positive side, so this way, it approaches -infinity.